Okay, kids, we're ready to rock and roll on day 4. Sorry this took so long to get up. Finally got it done today. But before I begin, before I do anything else, I want to say how very, very, very sorry I am. And how much I will be thinking about the family of the student who passed away and died last night. Still don't know the true facts. But what we do know is after 1 o'clock at night, this young man was outside walking somewhere, and he never made it to where he was going. So to my students, I want you to remember when I tell you, and I want you to think about when I tell you to take care of each other, to hang around the right people. I always say stupid people. Don't hang around stupid people. But what I truly mean by that is hang around your friends. You're teenagers. You're going to do dumb things. We know that as parents. Guess what? We as parents did it. But you need to take care of each other. There was no reason at 1 o'clock at night for some young 19-year-old boy to be walking alone by himself. Take care of each other. The heartache that family is going through right now, I can't even imagine. First thing I did this morning was woke my son up and called him and talked to him and told him how much I loved him. Because as a parent, that is the single worst possible thing you could have to go through. So to that family that's suffering right now, I am very, very, very sorry. For those of you that are friends of the family, I'm very, very, very sorry. But my students, I want you to remember, you need to take care of your friends. You need to take care of even somebody that's not your friend. It's part of being a human being. It's part of being life. You take care of each other. All right, guys, enough of the somber talk. I want to get rocking and rolling. I hope you guys truly enjoy every minute of your rest of your lives and outlive your parents and live forever and ever. But you have to make smart decisions, and you have to make really great decisions and hang around the right people, the people that will stay with you and protect you. And I just don't ever want to see one of my students have to go through this again. And I've been to too many wakes and calling hours in 20 years, and I do not want to go to any more. Anyway, Mr. Keys here, ready to help you rock and roll. I apologize for that, but it needed to be said. I couldn't go through this without having said that. Okay, I'm done. All right, let's talk about math then. I got 3 pages of notes, won't take very long. Maybe it's 2, maybe it's 3, I don't know. It's not going to take very long. But it is incredibly important that you understand what reference angles are. In fact, I got to find a place to write the definition. Here it is, right here. Reference angles are the cute little angle, you cute little angle, you little cute. That's less than 90. It's a cute little angle. Ooh. Okay, I'll never say that again, but it is a cute little angle. The acute angle formed, let's see how I say this, by the terminal side, and the x-axis. Let's see what we mean by that. Let's see what we mean by that, kiddies. All right, first things first, we'll draw in our initial side. There's our initial side. Now, don't draw these first couple in. Don't draw these first couple in. I'm just going to kind of try to make a point. If I gave you an angle that was in the first quadrant, that's already an acute angle. Let's say I said this angle was 25 degrees. Well, that's already a cute little angle. And it already forms an acute angle with the closest x-axis right there of 25 degrees. If I came in and I drew this angle, and I said that was 70 degrees, that would still be an acute angle that I can make with the... So in the first quadrant, we really don't need to worry about reference angles. The reference angles in the first quadrant are just those angles. You don't need to worry about it. What we really want to worry about is anything other than an angle that ends in the first quadrant. Let's say, for example, I give you an angle over here. And this would be the terminal side. So we could say this angle might be somewhere in the neighborhood of, I don't know, 140 degrees. Somewhere in the neighborhood of 140 degrees. That's not acute. I need a cute little angle, a tiny angle, and I need to make it with the x-axis. So what you need to do is figure out where the closest x-axis is. Oh, here it is. There's the closest x-axis. And I need to make that a acute angle. And this angle here then would be the reference angle. Because we're going to refer to it when we solve problems. We're going to refer to it when we solve problems. And you'll see how this comes to play in a minute. The first thing you need to understand is how I go about getting the reference angle. And then we're going to see how to use the reference angle. So in this case, since all the way around would be 180 degrees, this little extra piece then, my reference angle would be 40 degrees. And again, you'll see how we use it today. And then when I do the Spiral 18 video, you'll see again how we do that. So let's say I give you a theta and I say your angle measure is 250 degrees. By the way, over here, how did I get that 40? I took 180 and I subtracted off 40. So you're always going to do big minus the axis. It's always off of the x-axis here. So that would 140. And that gave me my 40 degree reference angle. Again, this has to be between 0 and 90. So I'm going to draw in my reference angle. There's my initial side. Let's see, that's 180. To go all the way to here would be 270, so I'm going to stop short. Now, I always get these kids that will tell me that this is the angle. They try to find the smallest angle. You don't want to find the smallest angle. The definition is the acute angle made from the terminal side and the x-axis. So in this case, to here was 180 degrees. That was 180 degrees. How much further did I go past 180 degrees? Or in other words, I'm going to take 250 and subtract off 180. What you need to do is just figure out what the positive acute angle is to the closest x-axis. In this case, it would be 70 degrees. So my reference angle in this case would be 70 degrees. What if I gave you a theta of, I don't know, 340 degrees? Well, all the way around is 360. There's my initial side. All the way around would be 360 degrees. And this is going to stop short. It's going to stop 20 degrees short. So again, I don't want to find how close it is to any axis. It has to be how close it is to the closest x-axis, which in this one would be right here. And that would be a 20 degree reference angle. So in this case, the reference angle would be 20 degrees. All right. So what you should do right now is pause the video and try to do these three on your own. And then what I would do is find the reference angle. And then I would do is scrub through the 5 or 6 minutes, or 3 or 4 minutes it's going to take me to get through these problems. Scrub through means fast forward through. Just kind of slide that slider across and see if you're right. If you're not right, back it up and see what you did wrong. So pause right now. Good. So there's my initial angle. 150 degrees would be somewhere over here. Sorry. And that would be 150 degrees. So in this case, the reference angle would be this little extra piece here. And in this case, I would take 180 and subtract off 150. And I would get a reference angle of 30 degrees. That's it. My reference angle is 30 degrees. Negative 45 degrees. Okay, so remember, going backwards. We're going clockwise. 45 degrees is halfway in between here. So this would be negative. I should have said a little bit more up here. I should have said the positive. I think I forgot that in there. The positive, I definitely did, acute angle formed with the terminal side. So in this case, I have a reference angle of negative 45 degrees. How far away is that? Well, my reference angle in this case, my reference angle would be 45 degrees. All right, down here. So first thing I'm going to do is convert this. I want to get rid of pi because I've got pi in there. That means it's in radians. And I want to get rid of it, so I'm going to multiply by 180 over pi. These pi's cancel. And when I multiply this out, I believe I get 405 degrees. All right, let's see, 405 degrees. That will be 360. And we'll just keep going a little bit more. About right there. And then I say, okay, how close am I to the closest x-axis? That's right here. Oh, my reference angle in this case is 45 degrees. So there's your answers. Ooh. All right, so why do we draw reference angles? And what we really want to know right now is, where are the positive functions? And I'm going to teach you a mnemonic device to learn this, so hopefully you'll remember in a minute. So let's say we take this triangle, and let's say it's a 30, you know what, it looks like a 45, 45, 90. Let's just do a 45. I drew it like a 45, 45, 90. So this is 45, and this is 45 degrees. So we said, and in our triangles yesterday, we said, well, let's make the hypotenuse 2, and we found out that these were the square root of 2 here. So, if this is my angle, this is opposite, adjacent, and hypotenuse. So in this case, sine of 45 degrees would equal square root of 2 over 2. Cosine of 45 degrees would equal square root of 2 over 2. And the tangent of 45 degrees would be equal to the square root of 2 over the square root of 2, which is just 1. Well, since all of these are positive, all of their reciprocal functions over here, their cosecant, which would be positive, secant of 45 degrees would be positive, and cotangent, oh, this should have been equal to 1, cotangent of 45 degrees, this would be equal to 1, and these two would be just the square root of 2. If you remember the work we did yesterday, these two would be just the square root of 2. But everything's positive things. All things are positive. All trig functions positive in the first quadrant. So in the first quadrant, everything's positive. Okay, let's take a look at the second quadrant. Now, this is 2. This is going up, so this is the square root of 2. But this is coming left, so I really want to think about that as being the negative square root of 2. Now, if I'm traveling out this way, it's in the negative direction, so this would really be negative square root of 2. So now let's look at our functions. I'm only going to look right now at sine, cosine, and tangent. So sine would be sine of my angle, of my reference angle. In this case, my reference angle is 45 degrees. So sine of 45 degrees would be the square root of 2 over 2, and it would be positive. The cosine, however, of 45 degrees is adjacent over hypotenuse, which would mean it would have to be negative square root of 2 over 2. So that's negative in this quadrant. And tangent of 45 degrees is opposite over adjacent, so that would be the square root of 2 over the negative square root of 2, so that would be equal to negative 1. So in this quadrant, which is the second quadrant, sine is positive. And since sine is positive, therefore cosecant theta is also positive. So these are the two positive functions in this quadrant. Oh, I'm going to make this easy for you in a minute. So in this quadrant, since I'm going down, this is also negative square root of 2, and this will always be just 2. All right, so let's see what we got here. In this quadrant, sine is equal to negative square root of 2 over 2. Cosine is equal to negative square root of 2 over 2. So those are both negative. And now when I get to the tangent, what I end up with is negative square root of 2 over negative square root of 2. So that's positive. So if tangent's positive, so is cotangent positive. So in this quadrant, tangent and cotangent are positive. All right, let's talk about that last one. I think you can probably guess by now. In this quadrant, this is negative radical 2, and this is still just 2. So over here I do sine is negative radical 2 over 2. That's negative. Cosine is positive radical 2 over 2. And tangent is negative radical 2 over positive radical 2. So what's positive in this quadrant? Cosine and secant are positive. So in this quadrant, where's my drawing? So in this drawing, in this quadrant, cosine and secant are positive. So how do I remember this? How do I remember this? Well, let me just give you a mnemonic device to remember this. And don't worry, I'm going to keep saying this over and over again. And it's A, S, T, C. All students take calculus. Now, you can come up with your own fun little device, but in this quadrant, all things are positive. And we always start in the first quadrant. Sine is positive, students. Tangent is positive, take. And cosine is positive. So, I could say, Allison Sawyer trips on cats. I don't know. Come up with your own fun thing. But it's on you. But anyway, so we're going to have to remember that in the first quadrant, all trig functions are positive. In the second, sine and therefore cosecant are positive. In the third quadrant, tangent and cotangent are positive. And in the fourth quadrant, cosine and secant are positive. All students take calculus. That's what I'm going to say over and over and over again in class. You can come up with your own if you like. If it's funny, maybe I'll use it. So, come over here. I'm going to go, okay, all students take calculus. You're going to see how this plays out on this page. So we're going to do through 4 steps. We're going to draw, we're going to find exact value, what? And sine. So let me just tell you what this means. This means no calculator. Or you could say use you brain. That's a good English. Use your brain. Use your brain. All right, so let's see how this works. First thing we got to do is draw it. 135 degrees, that would be right here. 135 degrees. So we drew it. Ka-ching. Find the reference angle. Okay, let's find that reference angle. So reference angle is the closest angle made with the x-axis. So if I take 180 and subtract off 135, I get 45 degrees. So I found the reference angle. Perfect. Oh, by the way, we're doing sine. So what is the exact value of sine? Well, let me draw my 45, 45, 90 right triangle. Ding, 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 ding. And 2, square roots of 2, square roots of 2. Now, eventually, I hope you just memorize this. 45, you're going to become to just memorize. Here's my angle, opposite over hypotenuse. So the sine of 135 is the square root of 2 over 2. The last step is, what is my SIGN? Is it positive or is it negative? So I go back, I go, okay, no, we're not that. Students, we're in this quadrant. Sine is positive in this quadrant. So there is my answer right there. All right, let's try another problem. Cosine 210. So the first thing we're going to do is draw it. Let me get a different pen. We're going to draw it. 210 degrees. We're going to go past here. And we're going to find out that this is 30 degrees. Because we're going to take 210, and we're going to subtract off 180, and we get 30 degrees. Or you can just count. That's 180 to here, 30 past. Okay. So now I want to think about cosine of 30 degrees. So if you draw, or if you've got it memorized, that would be better. I'm going to be quizzing you on memorizing this, so make sure you do. Let me draw a right triangle instead of a crappy triangle. So draw my right triangle. So we said 2, 1, square root of 3. Cosine is adjacent over hypotenuse, so the cosine of 210 degrees. Really, we're going to do of 30 degrees. So we're going to use that reference angle, and we're going to find the cosine of 30 degrees is equal to the square root of 3 over 2. But now I got to decide what kind of sine it's going to be. Let's see. All students take. So in this quadrant, tangent is the only thing that's positive, and of course cotangent. So therefore, this must be negative. See, the reason why, let me show you the reason why this works. If I draw a 300-degree angle, it's going to be down here. Nope, not there. It's going to be right about here. And I draw this triangle in. Well, it doesn't matter if I draw that triangle in or let me do it in blue. This triangle in. This angle is the same angle. So what we do is we use the reference angle. We want to find out how big it is because that angle is the same size in that triangle as it is in this triangle. So I want to find the positive acute angle. Even though this is my 310 degrees, my 300 degrees, this is a 60-degree angle. So that's what we need to use. So we go over here, draw in our 30, 60, 90, 30, 60, 90, 2, 1, square roots of 3. And I say, okay, what is the tangent of 60 degrees? Well, okay, this is my angle then. Opposite over adjacent. So the tangent of 60 degrees is equal to radical 3 over 1, or just radical 3. But now you got to decide what sign you're going to use. All students take calculus. So in this quadrant, which we're in, cosine's positive, so tangent is not. So the tangent of 300 degrees is equal to negative radical 3. Because again, this triangle here, what we're trying to do is figure out whatever. Sorry, I misspoke there. Anyway, let's do negative 150 degrees. So again, we're always going to find the reference angle of the quadrant, or the angle. So here's our angle. Here's our initial side. Negative 150 is, screw that up. Negative 150 is right about here. So what I want to do is I want to find this reference angle. Well, that would be 180. How far away am I from the 180? I am 30 away. So in this case, my reference angle is 30. So I'll draw my 30-degree triangle and label it 2, 1, square root of 3. And let's see, 30 degrees. Oh, I'm finding cotangent. I don't know anything about cotangent. I don't know nothing about cotangent, but I do know that tangent is opposite over adjacent. So I'm going to find this first. So let's see. Tangent of 30, which is the same angle as this, so they're the same measure. Tangent of 30 is 1 over radical 3. 1 over radical 3. So cotangent of 30 must be the reciprocal of this, which is just radical 3. So now I've got, so if I was in the first quadrant, cotangent of 30 degrees would be square root of 3. But I'm not in the third quadrant. I'm in the first quadrant. I'm in the third quadrant. And let's see. All students take. Tangent and cotangent are positive here. So this is, in fact, the answer. Well, what I need to write down is cotangent of negative 150 degrees is equal to the square root of 3. All right, let's see how we're going to use this. Oh, sorry. I was thinking of something else. All right, we're going to just practice. So first things first, let's convert to degrees. At some point, you might be able to start counting in radians. Put 180 over pi, ka-ching, ka-ching. So this is equal to 300 degrees. Initial side. Terminal side. Grab a different color. Reference angle is, ooh, I didn't draw that very well, 60 degrees. This should be really right more down here. But my reference, oh wait. What happened here? Am I on the wrong page? Did I miss something? Oh, I missed a whole bunch. Oh, all right, let me go back up here. Sorry. I'll come back to that one. Sorry, you guys are probably wondering what the heck just happened. All right, here's my angle. 315 degrees. I'm going to redraw that one anyway. Theta equals 315. By the way, if it ends in 5, there's a very good chance your reference angle is going to be 45. In this case, it is. I am 45 degrees away from this axis. So I say, okay, sine of 45 degrees, I hope you have memorized by now, is the square root of 2 over 2. Go back and look if you don't. All students. So sine's positive here and sine's positive here. So I know this is negative. So this is going to be equal to negative radical 2 over 2. Done. 120. Right? Right. Bad angle. More like up here. 120 degrees. So if this is a 120, my reference angle must be 60. All right, so let me see. Square root of 2 over 2, I think you should have memorized by now. This one you may not have yet. So 30, 60, 90, 2, 1, radical 3. And if we're talking about the 60-degree angle, we have to use the 60-degree angle. This is hypotenuse, this is opposite, and this is adjacent. So cosine of 120 or cosine of 60 is radical 3. No, it's adjacent. It's adjacent over hypotenuse. So adjacent is 1 over 2. So cosine of 120, we found cosine of the reference angle, but that's equal to cosine of 120, except for it might have a sign change, okay? So in the first quadrant, it would be 1/2. All students. So the only thing that's positive here is sine and cosecant. Therefore, cosine would be negative. 4 more, kids. That's convert. You know it's got to do. Anytime it's got a 4, by the way, it's going to have a reference angle of 45 degrees because 180 divided by 4 is 45 degrees. So 180 over pi. Pi's cancel. And I end up with 135 degrees. So so my reference angle is 45 degrees because this is 135. So I want to find the cosine of 45 degrees. Well, we know that one by now. It's the square root of 2 over 2. We've got that memorized, I hope, by now. But I'm in the second quadrant, and in the second quadrant, all students, only sine is positive in the second quadrant. So the cosine of 3 pi over 4, although it would be the square root of 2 over 2, it's really negative. So really what you're doing is you're just finding the reference angle. Because what you'll find out is that, and I hope you're starting to get this, that the cosine of 30 is equal to the cosine of 150 if you neglect sine. If you neglect the SIGN. The cosine of 30 is radical 3 over 2. The cosine of 150 is actually negative radical 3 over 2. But if you neglect the sign, they're all but equal. And that's because 150 is 30 away from the axes. So you'll also find that, let's say, the sine of 60 is equal to sine of 120. And sine of 60 is also square root of 3 over 2. Sine of 120 is radical 3 over 2. And sine is positive. So those are, in fact, equal. So these reference angles will tell us how to find these sizes. Just we have to determine what SIGN, what the sign is going to be. All right, let's convert. 180 over pi. Oops, pi. Forgot to cross out the pi. And this would be 210 degrees. So if you want, you can find the sine first. So the reference angle is 30. So what we're going to do is find the tangent of 30 degrees. Well, maybe look at that triangle again. Is it up here? Yeah, let me draw my other one. Let me draw a new one. A different color. I'm tired of that color anyway. So 2, 1, radical 3. Tangent is equal to opposite over adjacent, which is 1 over radical 3. So we gotta simplify, or we gotta rationalize this. Radical 3 over radical 3. So this is equal to radical 3 over 3. So the tangent of 7 pi over 6 is equal to this. We just got to look at the sign. So let's see. All students take. Tangent's positive down here. So there is, in fact, your answer. 2 more. So, convert. Pi's cancel. And I get 300 degrees. So initial side, terminal side, not quite great. So my reference angle would be, in this case, 60 degrees. All right, so I want to do the sine of 60 degrees. So 30, 60, 90. Hypotenuse is 2, the shortest side is 1, the square root of 3 goes in the middle. Sine of 60, so we're going to use this angle, is opposite, which is radical 3 over 2. So this is equal to radical 3 over 2. Now you got to come through and talk about what SIGN we have. All students take calculus. So cosine is positive down here, therefore sine is not. So therefore my final answer is sine of 5 pi over 3, since it is in fact in the fourth quadrant and sine is negative in the fourth quadrant. The answer is negative radical 3 over 2. All right, so multiply by 180 over pi. The pi's cancel. And I get negative 210 degrees. Okay, well, that's similar to what we had before. That was 180. Go a little further. So in this case, my reference angle is draw that little triangle with the right angle, with draw that triangle with the x-axis. My reference angle is 30 because I went 30 past 180. So I want to find the secant of 30 degrees. Okay, I don't know anything about the secant of 30 degrees. I want to find the cosine of 30 degrees. So I'll go 30, 60, 90, 1, 2, 1, radical 3. So the cosine of 30, is adjacent radical 3 over hypotenuse 2. Radical 3 over 2. Therefore, the secant is the reciprocal of that, which is 2 over radical 3. Multiply by radical 3 over radical 3, and I get 2 radical 3 over 3. So now I know what secant of negative 210 degrees. It has a magnitude of 2 square roots of 3 over 3. I just don't know if it's positive or negative. So all students, sine and cosecant are positive here. Therefore, this must be negative. So the secant of negative 7 pi over 6 is equal to negative 2 square roots of 3 over 3. And I believe that's the last problems, kids. All right, hopefully you got it. And once again, take care of each other. This was a very, very, very nice young man. Always smiled, always had a positive attitude, always having a great time. Something awful happened, some tragedy happened, and I don't want that to happen to any more Hilton students. And if I can do anything to save you from that, I will. And I'll beat you over the head with all these lectures until you figure out that maybe sometimes parents and your teachers are right. And don't forget, you can always call your parents. All right, guys. It's been fun. It's been real. And it's been real fun. All right, bye.